welcome to your first breakout session at Build. Thanks for coming over. I know for some of you it was a long way here, and for some of you it was a long wait to get registered. And so thanks for persevering through that, and it's good to see you here. My name is Tariq Madkour. I'm the Group Program Manager for the Visual C++ team. I've been on the Visual C++ team for a little over 11 years now. Worked on different parts of the tool, from the IDE to the compiler to the libraries, and now I'm happy to talk about any piece of it. At the end of the talk, I'll stay around here for more questions, and there's plenty of room outside. We can go and chat as well. One of the best things about this conference this time is that it's here in Redmond, so that's basically where all our team is. So we'd certainly love to chat and have offline discussions with you. Just come find me after the talk, and we can do that. We can even prepare for longer discussions with more members of our team, if you so wish, because they're all here and would love to chat with you. So, well, thanks for coming again. The title of the talk is pretty self-explanatory. I'm assuming you're here because you have C++ code. How many people are C++ developers? Everybody? Almost everybody? Good. All right. So you have C++ code. You're interested in Windows 8, I'm assuming? Windows 8, okay, good. Right. How many people have already submitted an application to the App Store? All right, maybe like 15 people or so. It's great, thank you. How many people are close? Close. Oh, so close, about 10, good. And the rest of you are really wanting to get there, so maybe we'll learn some of the experience of people who have gone through this experience. Feel free to share as well. I want this to be an interactive session, so don't hold back any questions. If you have questions while I'm talking, just raise your hand or shout away. These microphones are great because that allows everybody else to hear your question. It also allows people in the recording after that to hear your question. If not, I'll repeat the question. So feel free to do that as well. And feel free to stop me during the discussion. If I can't see you, try to get my attention. Just don't throw stuff. All right? Let me get switched to the right screen. Okay. Okay, so we'll talk to you about how to get your C++ code to the Windows Store world. So you already have existing C++ code, whether it's for a Windows desktop application or C++ code for an application that is not on Windows. Who's coming from a Windows desktop world? Most people. Anybody doesn't have a desktop application, just coming from a different operating system altogether? A couple. All right. So it's going to be a little bit different based on where you're coming from. Most of the people are coming from the desktop world, so I'll orient my talk towards that way. I'll talk first about the key differences between the desktop world and the Windows Store world. And it's important to understand those conceptual differences because it will have an impact on what kinds of areas in your application that you want to change. We'll also talk about more of the lower level. Okay, let's go at the API level. What does that really mean in terms of changing? What needs to change? What new APIs are available and how to use those? Talk about some of the patterns for these APIs. And lastly, this talk is equally valid for both if you're creating applications or if you're creating libraries. Anybody who's a library vendor, like strictly you're not creating apps, you're just creating libraries. A handful, okay, more than a handful. So if you're creating libraries, or even if you're creating applications but are interested in doing them with multiple languages, sometimes it's very interesting for you to go figure out how to get your C++ code exposed to the rest of the world. So we'll talk about that a little bit. And of course, all throughout, we'll be doing demos and showing some of that really in action. All right. So what is different between the Windows desktop world and the world of Windows Store applications? I like pictures, and I tried to pick what picture to put in there, and I think the most telling one was one of a tablet. In this case, I think it might be the Surface. It's not really the Surface. Okay. Why did I pick this one? I think this picture really embodies the key differences that you need to personalize when you're thinking about your application in the desktop world versus a Windows Store world. This is how your user is going to be consuming your application. In the desktop world, somebody is sitting at a desk. They have a big screen. They're connected to a power supply. They have a mouse. They have access to a keyboard. The setting is very different. This, they're most likely sitting on a couch. using their fingers. There might be some keyboard, but it's either an on-screen keyboard or something better than that, but really probably not a full keyboard all the time. Power is very important. You don't want to keep getting connected to the power, to the charger all the time. You want to be able to move with it. You don't want to keep charging it every 3 hours. It's not like a laptop. So while the laptop kind of bridges both worlds a little bit, this is still like very, very, very power demanding setting. There's also the issue of trust. On the desktop, in the desktop world, I happen to be the IT guy for our family. How many people play that role in your family? Okay, most of you. Good. You're familiar with what I'm talking about. So, part of my regular visits to my family, one of the things I do first is I sit on their computers and I start removing, uninstalling software that they put there. They have no idea how they got that software on there, really. And I keep telling them, why do you install that kind of stuff? And they're like, what do you mean by install? And I don't know what you're talking about. I just collect stuff. Okay, good. So one of the fundamental value propositions for Windows 8 was we want to change that world for our users. We don't want consumers just getting apps that they have no idea how they got, apps that are able to pretty much do anything, including get access to your credit card numbers and send them to some crazy server somewhere else in the world. So we wanted to control that a little bit. So we wanted some trust in those applications. So it is very important that any application that you create maintains that trust. And what does it mean to have that trust? It actually has implications to you at the API level. So we're going to talk about those as well. And last but not least, performance. Performance continues to be a very important thing. While the desktop is probably a very powerful machine, and the laptop is not, the expectations from a consumer perspective, the people who are actually using their application, does not degrade because they're using a tablet. They probably expect equal performance in the application there. In some cases, actually, they expect better performance just because they're now interacting with it directly and it's so close to them and they're just using their hands to do stuff. So people expect real-life interaction just like you physically interact with objects. There's not that mouse and keyboard in the middle. So user studies have actually shown that on a tablet, actually different from a phone, on a tablet, people have raised expectations of how fluid an experience needs to be. So that also puts some stress on you as a developer. So these are just some of the fundamental differences that exist. And when you're thinking about taking your application or your code in general from the Windows desktop world to the tablet world, that's one thing that, these are some things that you have to keep in mind. So what does it mean for you as a developer, right? Well, obviously, because there is a new user experience, Windows 8 itself has a different user experience. Your application should play in that user experience. It is highly unlikely that any of the UI that you have today for your application will make sense in that world. For some, it might. But for 99.9% of the cases, it just doesn't. And most of the time, you just need to change that UI, and you need to rethink your UI. The other things that you go beyond the UI, you start thinking about the actual code for your application. And to live in that new trusted world, not all APIs that you had access to, you'll be able to have access to. There will be some restrictions on what kind of APIs you can do. Now, you're all here because you're C++ developers, and C++ developers are very proud of being advanced developers. You really can do a lot of stuff. You can do a crazy pointer math that nobody else understands. You can call any operating system APIs. You're probably better than threading than most other people are. That's great. And we want to make sure that you can continue to leverage that investment. So we're not talking about completely changing your world. But with that said, some of the things that you could ask the operating system to do in the past, they're kind of dangerous. And you could get away with it in a world where some applications were allowed to misuse or abuse those same APIs. So what we did was take some of those APIs and change them and say, like, they can't do everything that they could do. They could do a subset. And the other subset they can't do anymore. So this has implications on your application as well. In terms of performance and responsiveness, one of the things that we're putting forefront is blocking, trying not to block applications. And one of the important patterns that you're going to see in most new APIs coming out of Windows is that they're asynchronous APIs. You execute an operation, you invoke an operation, and then you do other stuff while you're waiting for a result. When the result is ready, you're going to get notified, right? So this is going to be an important pattern, so we'll talk about that pattern too. So these are some of for you as a developer, using new APIs, changing some of the existing APIs that you have, a different user experience for your application, some elements of trust, using asynchronous. These are all things that you're going to have to deal with, and we're going to cover in our presentation today. I'll spend a little bit of time on user interface. Really, most of my presentation is geared towards the actual code that you have. Since user interface has to be significantly changed, and there's so many UI technologies to pick from, there are lots of other sessions at Build who will actually go and discuss this topic at length. So you're going to hear, you're going to see HTML and JavaScript sessions. You're going to see XAML sessions in C++ or in .NET. You're going to see DirectX sessions. So many to choose from. Pick the ones you're interested in and go to those. For now, I'll just stay at your UI is going to need to change. Some of the reasons it's going to need to change is obviously because it's just a different form factor, smaller, more touch-friendly. The interface is a little bit different. The input is a little bit different. But also because Windows 8 provides new services. So your application has to have a certain aspect ratio, and it's going to snap in one of two modes. And it has to scale well to that kind of snapping. Also, your application needs to participate in the rest of the Windows 8 system. So it needs to be able to share and talk to devices and do all the things that a Windows 8 application can do. How many of you have already used Windows 8? More than half the room, okay? Anybody has a Surface yet? Lucky you. Lucky you. I don't have mine yet. I don't have mine yet, so I'm jealous. I'll play with it, sure. I'll take you up on the offer. So for creating those new UIs, for you as a C++ developer, if you are already using DirectX, any DirectX developers? 20 or 30, okay. If you're using DirectX, DirectX is actually shaping up to be one of the UI frameworks, if I can call it a framework, that is spanning the breadth of the Microsoft platforms. So it's on the desktop world. It's available for Windows Store apps. Now it's on Windows Phone. It has always been on the Xbox. It's pretty much any interesting consumer-focused device. DirectX is there. So it's actually one of those portable in the Microsoft portable sense of the world. So it's a good in that way. There's also XAML. That's a new UI framework that we created for Windows 8. XAML is not new. XAML has been available in the .NET world on the Microsoft platforms forever, for, I don't know, 8 years or so. And we're just taking that now to be available on Windows Store applications and available specifically for you as C++ developers, which never was before. You had to go through .NET to do that. So the XAML available in Windows 8 is 100% native. No .NET coming in the picture, no CLR coming in the picture, no garbage collection, 100% native down to the middle. And you can use that as your UI framework. You can also, as a C++ developer, have UIs in C#, in Visual Basic, in JavaScript, HTML5, and then have those interact with a C++ backend. So these are all possible alternatives for you. Again, I'm not going to go into details this time around. Lots of other sessions for that. But the key message is you need to rethink your UI. These are very good technologies for you to do that. And Visual Studio has some great tools for you to actually be able to create those UIs. Again, I like pictures, and I thought hard about which picture to put. Anybody played with the Fresh Paint app? Anybody saw this app before? A few. If you haven't, and you have access to Windows 8, it's a free app created by some folks at Microsoft. You should go try it. It's a really, really beautiful app, written in C++ all the way. And it actually does something really cool, which is a combination of both DirectX and XAML. The application allows you to paint with your fingers, and they actually use this to get some real nice art done. And it's painting on a canvas, and there are different kinds of canvases, and they have the paint simulate the real action of paint with a brush when it goes on that type of canvas. So some canvas have higher ridges, so the paint behaves a little bit differently than on flat paper. Some things smudge, some things don't. So they're doing all these real-life simulations with code. And to do that, you really need to have high-performance graphics. And you can only do that with DirectX. But also, there are controls that you access things with, and DirectX is not geared to that. So all these things here in the center, this is all DirectX painted with your finger. Your finger and the application is responding with DirectX. Everything on the top here and everything on the bottom here, these are actually XAML controls. Even this very nice paint thing here, this is all XAML. This is a button. This red thing that I'm looking at is actually a button with XAML. This application is openable in the XAML Designer in Visual Studio. I have the code for this application, and when I open the XAML Designer, this is what I see in front of me. So this is the kind of high-fidelity designer that's available in Visual Studio that you can do. This is also the kind of framework support from a UI perspective that you can create these kinds of applications very easily. It's called Fresh Paint. Yes, there's a question.
There's a runtime called Windows RT, and then there's the backwards compatible version of Windows 8. In the context of your talk, are you referring to both of those environments, or only the backwards compatible version?
So the question is, there is a runtime called Windows RT, WinRT. There's an API called WinRT, and there's a backwards compatible version of the APIs. In my talk, am I only talking about one or both? We'll talk about both. We'll talk about new WinRT APIs, and we will talk about existing Win32 and COM APIs and how those apply in the Windows Store world. Right? So that's enough for UI. Let's start talking about APIs. So to answer your question, yes, Win32 and COM. So if you think of your application as a view and a model, view we've taken care of. You need to rethink your view. Done. Okay? Now, very easy. You can give it to somebody else, right? Piece of cake. It's a long thing to deal with, and it needs its own talk. So you've got those for the view. Now let's focus on the model, and this is where the rest of my talk today is going to be at. So for the model of your application, your old code, business logical, algorithmic stuff, or any other stuff, different types of code you could be using. You could be using standard ISO C++ stuff. You could be calling into operating system APIs. You could be doing a lot of things. Let's take them one by one. Okay? You're calling into operating system code. Win32 and COM APIs abound. Okay? What happens to those? Well, as I mentioned earlier, use to those APIs are restricted. Not every API that was available is going to continue to be available. Some of them are restricted in terms of they can't do everything that they did. Some of them are restricted in that they're just not there, and there are replacements. Some of them are restricted in that they're not there, and there are no replacements. So you just have to rethink what you're doing. It's just a concept that doesn't apply in the Windows Store world, or we don't want it to apply in the Windows Store world. You can see a world where it applies, but we just don't want it to apply. For example, inter-process communication. While this is a great thing, and we've all relied on it in the desktop world, because you could rely on an MSI that installs 3 applications and they know how to communicate. You will always guarantee that they will be on every user machine. That's not the case here in the Windows Store world. Apps are isolated. No app talks to other app except on specified contracts using the Windows 8 contracts. You can't create your own contracts. So having a Windows 8 app be dependent on a desktop component is just not possible. We don't want you to do that because not every person who downloads your app is going to necessarily have your desktop application. So we don't want that scenario. So we completely break it. Those APIs are not available. The question. So the question, can that all be done with sockets? So you'll notice that access to sockets are also restricted. Not everything. Of course, you can communicate with the internet and all of that. But listening to a port on the local host or getting, sending stuff to local host, some of that is also going to be restricted. But what is available is the very rudimentary access through files. That's basically what's there. So, but no, you cannot really, if you try to work around this by getting a desktop app that sends something through sockets to a Windows Store app, that won't be possible. Question at the back.
Is there a clear list of what is available versus what's not available so that we're not playing a hunting game?
Good. So the question is there a clear list of what's available and what's not available so that we're not playing the hunting game? Yes. So there is a couple slides from now, we'll go through a demo of how to find the APIs in your application. I'll also show a website on the Windows Development Center that actually lists all of those. All right, so more questions?
Are the API restrictions only due to security, or are they also due to performance and other reasons?
There are lots of other reasons. Security is certainly a big one. It's a very, very big one. There are other reasons. For example, some APIs changes were made because the versions that we have are not very battery friendly, or they allow you to create, long-running threads that are expected to be 3 hours running, and we don't expect that kind of behavior for Windows Store applications. So some changes are not related to that. Some of the API changes are GDI is gone. We just don't want you to go creating desktop kind UIs in the Windows Store world. So so those also go away. So it's multiple concepts, not just one.
How close are you with Drupal development with widely used libraries like Roost and OpenSSL and the like to make sure you can hold them to run in this state?
Okay. The question was about third-party libraries. I'll ask you to wait on that one for a few minutes. Okay. All right. So not all APIs are available. Some APIs are changed. You will notice here, the example I have on the right is CreateFile. CreateFile is one API that is not available. What happens if you use an API that's not available or that is restricted? The number one thing is, at runtime, some of those APIs will just fail in unexpected ways from the desktop world. So that's one thing. Your application might even fail to load. More importantly, and that's just failure in terms of you debugging it on your machine. But more importantly, if you're actually using an API that is restricted, your application is not going to be allowed in the App Store. Every application goes through a certification process. Those of you who've done Windows 8 application, submitted an application already know that. You submit it to the store goes through a bunch of checks, and then they reply to you with, like, yes, your application is there, here it is, or no, you've got these issues to work through. So one of the issues that they can submit it back to work through would be, hey, you're using these APIs. Every application is going to go through a binary check. They check through all the imports that you have, check what APIs you're calling from which DLLs in the operating system. If you're calling anyone that we don't like, your app is not going to be approved. Can you use getproc address and load library and that kind of stuff to get around this? No, because getproc address is not available. Question?
Are there ways that you install an app into WinRT outside of the Windows Store?
Can you install an app from outside, a Windows Store app from outside the Windows Store, like a WinRT app from outside the Windows Store? You can if you jailbreak your machine, like as a developer, you have a developer license, yes, you can. I'm sure there is something for businesses or the other. I'm actually not sure exactly what that thing is. But for consumers, like for the typical consumer, no. All right. So basically, your app will get rejected. Somebody asked about third-party libraries. Third-party libraries are included in that check. So if you're deploying your own DLLs or your own executables as part of the package, those are going to be checked. But also, if you have a DLL that you got as part of a third-party library or a static library that gets linked into your executable, those are also going to be checked. So you need to make sure that any third-party libraries that you're using are clean. Now, what are we doing in terms of helping? The question was, are you working with other third-party providers to make sure that their libraries are going to be available? We're working with some. We think that much of the push is really going to happen when a lot of developers are starting to need that. And there's going to be the working through library vendors to actually get the work done. This is no new story. Like every time we've released a new version of Visual C++, if you relied on a third-party library, you always had to go to that library vendor and make sure that they have a version that's compatible with the version that you need. In this case, the changes that they need to do are just more significant than before. So it might take longer. But basically, you should be working with your third-party vendors. If you already bought code from somebody, and you have access to that code, you need to go through the process of actually moving that. If you've inherited a binary from somebody, hopefully you have the source for it. Because if you don't, that's not going to be a pretty picture. In general, you really shouldn't be getting binaries from people and just deploying them without access to source. But that's so condescending. Sorry. Shouldn't have said that. Can you get source from you then? Can you get source from me? Good question. Can you get source from me? You don't want to get my source code. All right. So we talked about operating system APIs. UI layer, things that you've already been using like MFC, not going to be available. GDI is not going to be available. DirectX is there, but as we said, you need to rethink your user experience. So while the actual application, the actual APIs are there, you just need to rethink how the UI looks like. Let's go to the actual code. If you're using ISO C++, you're using just standard code, you're in good shape. Nothing needs to be changed. Anything that you've used there will continue to work just fine. Our own implementation of libraries, we made sure that these continue to work in the Windows Store world. So if you're relying on Visual C++ libraries, you're going to be in good shape as well. Some of the runtime libraries that we created that are proprietary to Microsoft, we also made those work. So whether it's some of our extensions to our C runtime, or whether it's things like the parallel patterns library, or even new language extensions like the C++ AMP. Anybody uses C++ AMP? Anybody heard of C++ AMP? A quarter of the people. C++ AMP is I don't think we have one talk about performance that we'll touch on AMP. It's all about performance. You should go to that one if you're not familiar with it. It's a technology that allows you to do general purpose computing on the GPU. It's the kind of speedups that you're not talking about 1.5x or 2x. You're talking about 100x speedup in terms of some workloads that you have. It's really, really good just directly in C++. Beautiful technology. But you can go find out about it more in a different session. There's a question?
Yeah, real quick. The list right here, is this independent of the CPU that's being targeted, x86 or ARM?
Good. The question is, the list right here, is this independent of what is being targeted, ARM versus Intel, x86, x64? Yes, it is. At least for everything other than third-party libraries. I don't know what about third-party libraries, but everything on the top here is the same for the different architectures. If you're doing C++ CLI, that's the one Microsoft extension that is not available in the Windows Store world. Anybody uses C++ CLI? About 20, okay. So for you, the alternative is really, if you really have to still do .NET to C++, and many people had to do that because some things were not available in C++ that they're now available. But if you still need to do that, WinRT is now the way for C++ and C# to talk together. It's actually the way for C++ and JavaScript also to talk to each other. So in a sense, by using WinRT as the interop method instead of C++ CLI, you gain access to more people you can interoperate with. Common ATL, mostly there, with the exception that you can't rely on globally registered things on the machine. So you can do res-free COM if you want. You can package a COM component in your application and use manifest to be able to find that, as opposed to going through the registry. But other than that, most of common ATL is there. And we talked about third-party libraries. So what do you do with those APIs? First of all, how do you find in your own application what APIs you're using that are restricted? I talked about a website that I'll show you, but other than browsing a website, finding a list of a few thousand APIs, and trying to hunt them down in your application, there are really two ways to do it. One that I prefer, and one that I call not recommended because not because it's bad, but because it's not the most expedient way. So maybe a better word would have been expedient and not expedient. The way that I prefer, this is after helping a lot of people go through porting their code, is to use the Windows Application Certification Kit. Basically, create a new XAML C++ application, add the DLLs that you've already created on your desktop world to that, add them to the package randomly, don't even use them, just add them to the package, and then deploy that and try to run it, okay? Doesn't matter if it starts or not. Then go to the Windows Application Certification Kit, and it's going to enumerate all the applications on your machine, and go point it at the one that you just deployed, and say, please check that one for me. It's going to do a lot of checks, and it's going to take, I don't know, 5 minutes or so. And at the end, it's going to get you a report of how your application is not compliant. There are going to be a lot of irrelevant things because obviously you're not even creating a Windows Store application yet. That was a very, sad attempt at creating one. But what you're going to be able to see there is the list of all the restricted APIs that you're actually using. This API and that DLL, this API and that DLL. Create that list, this is your hit list, and then use your favorite IDE to go figure out where you're using them. And that's the fastest way to getting your API Windows Store clean, getting your API usage to be Windows Store clean. The other way is to use the compiler. Just set the macro. There's a macro that specifies that you're targeting the Windows Store world. Set that macro to the correct values and build your application. You're going to get compiler errors and go through them one by one. Why is this my not recommended approach, even though it's actually a lot faster and iterative in terms of you build and builds, even though builds in C++ are not the fastest thing. They're still faster than going through the Windows Application Certification Kit. But you'll see that a lot of the APIs you use, you need structs, and those structs are then just not available. So you start getting random errors in places that are different from where you're actually calling these API about, the tag point blah struct is not available, or just actually all you're going to get is undefined symbol. So And that's a lot of stuff to go through. And then you're not sure exactly what you use this struct for, and is it used in this API, and you use it as part of the data in some class that's called from somewhere else. Just it gets very, very confusing very quickly. It's just a lot easier to go at the API level and then go make all the changes that need to happen based on that API, based on changing that API. Once you're there, once you're done with number one up here, and you think you've got all the APIs out, then enable the compiler, set the preprocessor macro, and work through the rest of the errors. But you're going to find that you're a lot faster if you go that first route. Any questions before I go to a demo of showing you how that works? One question, yes. A couple of questions, yes.
You mentioned replacement APIs. Those replacement APIs can be Windows 8 only, or do they have backward compatibility with previous versions?
Replacement APIs, are they Windows 8 only, or do they have backwards compatibility? There are options. There are some options that exist that are backwards compatible, and there are some that are Windows 8 only, and it will depend on the API. So I'll talk maybe 50-50. I don't know. Yeah. Yes?
Just to follow up, so but everything that can run on Windows on the App Store can run on Windows 8 desktop, right? All those APIs.
Okay. The question is, everything that can run on the App Store can run on the desktop. For Win32 and COM, yes. For new WinRT APIs, no. All right. So let's go through an example. One of my colleagues at work, oh, this is funny. Okay, stop that. Go back to this. Okay, now we can see Visual Studio. One of my colleagues at work created an application for face detection. Just to give it a bunch of pictures, and it is going to detect faces on those pictures. Very simple and straightforward application. They use an open source library called OpenCV that provides functionality that enable things like face detection. So they built a library on top of OpenCV. So they had to go through porting their own library and then porting the third-party library for which there was no Windows Store equivalent. So how do you apply the techniques that we showed to this? So this is just a very simple application. It's a XAML application with an empty XAML page. Absolutely nothing in it, just completely empty. And what I did was I added a reference. See, designer is just empty. I added a reference, if you look at the references, to a WinRT face detect SDK, which is the set of, and I'll talk a little bit about how to create one of those packaged references for libraries. They went and created something called an extension SDK for their library. It's a new concept in Visual Studio 2012. It's a way to allow you, as somebody who creates a library, to package all the DLLs, headers, libs, all the things that are needed, and if there are any compiler switches that need to be thrown for your library and all of that, package it in one package, and then have somebody drop it in a specific path in Visual Studio, and all of a sudden they can just add a reference to that. They don't need to mess with include paths, lib paths, adding a library, any of this. So they created, and I'll show you very quickly how to create one of those later on. But they added this, I added a reference to this desktop version of the face detection library. This is exactly as it is used in the desktop application. And I'm going to run it through the Windows Application Certification Kit and see what comes out. Yes? The question, what was what called? Yeah, the question is, what is the thing I'm talking about called? It's called extension SDKs. Okay. And it's documented in the Visual Studio documentation. Okay. So I'm going to go through this. I've already packaged the application and built it and tried to run it, and nothing came up. So what I'm going to do is I'll do Windows App Cert Kit. This is the application you want to run, Windows App Cert Kit. Yes, I need to be admin. There you go. This is my favorite part of Windows. WAC? Is the acronym deliberate? WAC. You know, WAC is the internal name that we keep using all the time. When I created my first iteration of the slide deck, it had WAC everywhere, and I had the people reviewing my slide flag it as an inappropriate term. So I'm not sure it was deliberate. Maybe it was. a number of options to choose from. This is the same kit that does the logo certification for desktop apps. It's used for a variety of reasons. The one you care about is the top reason, which is validate a Windows Store app. When I click on that, it's going to take its sweet time and then come back with a list of all the deployed applications, deployed Windows Store applications on my machine. And that is why it was important that you can't just create that. You can't point it at an exe or an Apex package. It actually has to be deployed on the machine. That's why you just go create a random application, put the DLLs in there, and start deploying it. When you do that, you're going to see all the applications that you have here. In my case, I can select the OpenCV test that we created here, right? And I can click next. It's going to take about 5 or 10 minutes. It's going to keep running their application a number of times because it checks a lot of things. It checks the startup time for your application. It checks what kind of contracts you're going to use or not. It checks the API usage. It checks 1,000 things and produces a big report at the end, which I will show. There was a question in the back. Assuming that it doesn't find any problems, is it a guarantee that it will be allowed in the store? Absolutely not. I think it's a technical guarantee that most likely, technically, you're just fine, but you could be doing a lot of things that violate a terms of service, including capturing things you shouldn't capture, showing things on the screen you shouldn't show, and these things cannot be verified by a tool. There's a question, then I'll come back to you. If you have SSE intrinsics that are x86 only, as in like not ARM, not valid for ARM, like yeah, it's not going to do that. I don't think it's going to do that. So yeah, so if you're using intrinsics by yourself to do like auto vectorization of your code, and then you'd have to do an ARM version and an Intel version. I don't think it's going to flag that now. I don't think it's going to flag that. I should check. I should double check and find me after the talk, and I can double check that for you. But I'm almost certain that it won't flag that. Yes. What indication is there that it's running? It's actually not running. I did not click next, and I will not click next because unless you want to watch it for 10 minutes, flickering the screen and showing my empty application trying to start up. However, with that said, once you run it, what you're going to get is an image that looks like this. Big field in the middle, right? And click here to view the results, okay? So I saved you all the trouble because that's where you're going to find out at the end, because obviously you did not touch your application. You should not expect that it's going to pass logo certification. Otherwise, all the differences that I talked about would be absolutely not a point at all. So when you click to view the results, these are the results I actually got for this application. I think it was this one. Here you go. You get an HTML page, and that one shows you what passed and what didn't pass. My app obviously starts fast enough because it doesn't do anything, and it doesn't crash or hang. Good. It fails a number of things because it's not built the right way. Why is it not built the right way? All applications submitted to the App Store need to have safe exception handling turned on, need to have a number of features that are turned on, NXCompat, these kinds of things need to be turned on. Obviously, I just prepackaged some libraries and DLLs that were absolutely not meant to be targeted for the store. Once you recompile and rebuild those libraries, you wouldn't have a problem. But you can ignore this section for now. The part that you're interested in, I'll come to your question. The part you're interested in is this, failed supported APIs. And this is a very interesting. Can you read it from here? Do you need me to zoom in? Good. So this list tells you this API in that DLL. So that OpenCV imageproc 233d.dll uses get module file name and load library EX and load library and elsterlen A and co-create instance and create file and create file mapping and a lot of other things. Okay. So you can go through them one by one, and this is your hit list. You'll find that sort of similar APIs in the different DLLs. Right? It's the same API repeated in multiple DLLs. Take that to your favorite Excel spreadsheet and find your list of 20, 30 APIs typically that you're using that are restricted and work your way through that. There was a question? Does this tool also run on the Windows RT version for ARM? Visual Studio in general doesn't run on ARM.
The reason I asked is because I
Okay, so you can do profiling on ARM devices. Like if you actually want to do software profiling on ARM, you can do that. There are tools that allow you to do that, including Visual Studio. This certification kit does not run on ARM. And the one test that it does for performance, and specifically startup performance, you could really do yourself with a stopwatch. So I think there are other things here at play. Let's talk about it after the session. I'd love to learn a little bit more about the specifics there. But in general, there are ARM profiling tools. You have those. Yes?
You mentioned looking at something that's you have libraries that are written in plain C rather than C++. What happens?
If you have libraries that are written in plain C rather than C++. Good question. Yeah, you can build it as C++ for sure. I think we've changed things a little bit from beta to RTM, so I'm not sure where we ended up on that one, whether we ended up completely not allowing C or not. I think we don't. Yeah. Yeah, you have to build it, disable it as C++. It's good that we have people who've tried it. Good.
But I mean, the existing C code isn't going to structure itself as C++ code. How long would be the rewrite all your C?
No, you don't need to rewrite all your C. I think it's just in terms of just like the binary itself having the bits set on it. But other than that, I think you're fine. Yeah, it's not going to go like check every function call and make sure that you're indeed like catching these kinds of exceptions or raising these kinds of things. Yes. Device I/O control. I would assume so, yes. Yes, that would be a very good assumption to make. Okay. Is there a path forward for applications that are intended to interact with hardware? So applications in general can talk to APIs raised in Windows services, for example. So if you have a hardware thing and you have a way to get your like special hardware that needs some special, you put a device driver on it and you can have a Windows service that others can listen to, you could do that. That would be one path to do it. I'm not sure if there is actually a way from the valid Windows Store APIs to directly talk to hardware that way or not. I'll need to double check offline. So there might be a way to do it directly from the app. But if not, it's really like you have to create the hardware with a driver and a service that exposes this thing to the applications.
That's the classic Win32 model?
That would be absolutely classic Win32 model because you can't deploy those things generally. Yeah. You cannot deploy services through an app store, yes. Correct. And in general, I think the reason we do that is we don't want an application available in the app store. We have no means of saying this app is only available to the devices that have this kind of device, of thing attached. So whatever application you put should be able to deal with all kinds of machines out there. So it's a very niche and unique scenario. Yes.
I was reading a video about that because we have a piece of hardware that requires, they use this application that uses that. So
That uses what, sorry?
this hardware.
Yeah.
So today in the code, and somewhere I read that when you connect the device, the driver should pull from the driver store, and this can come with the app. Now it will be the app that runs in the new call it natural style, or is stuff to desktop on.
So in general, just dealing with devices and creating the device drivers for these devices is going to be beyond what I want to talk about here. But yeah, in general, there's no way for you to just automatically deploy a Windows Store application with that said. Now, with that said, there is a way. There are some APIs that you can call from your desktop application to install packages. That is possible. So you're going to have a desktop application that is an installer that installs your device driver and does all these things, and then potentially also install a Windows Store application for the customer. But they're going to get asked for it. It's not going to be an automatic thing. It's going to be a different user experience. Right. So we ran this. We got the list, a set of APIs. I can go to Visual Studio. And this is another Visual Studio here. I can open the actual OpenCV library that I have. And this has all the code for the OpenCV library. And what I can do then is I like to use Visual Studio to just find, say, create file. Somebody noted create file. How can I find where create file is used? My favorite feature in Visual Studio is this Navigate To. Everybody familiar with Navigate To? No? Oh, it's the most beautiful feature of Visual Studio in my opinion. Control comma for C++ developer. Hit control comma. And then you could just type anything, whether it's a file name or an API, symbol, anything you want. Okay? It says go, it said I think it's got create file A. I'll go to create file. Here it is. It opens it in file API.h. I want to see the references to create file. Right click, find all references. This is where it's defined. This is the pound defined that says, W versus A. This is the one where it's actually defined in the header file, and this is the place where it's used. This is basically where you're calling create file in your application. And you can do that for the different APIs that you have, put the bookmarks or whatever it is on the areas that you want to change, and then go through them one by one. This is how I personally like to do it. I talked a little bit about the WinAPI family partition. This is actually what's happening inside Windows.h and all the other headers you're getting from Microsoft. Let me close this part. You will notice here on top of create file A, it says if WinAPI family partition, WinAPI partition desktop. So a lot of those APIs in the header file, they exist. You can see them in the header file. When you're compiling, because Windows Store applications set it to not be the partition desktop but partition application, those APIs are basically if-deffed out, and you never get access to them. I talked about the website that lists all the APIs. So this is the Windows Dev Center. Just go to your favorite search engine, click, find Windows Dev Center, and there you should be able to find the API reference. Of course. Oh, good. And in there, look at Windows APIs, Win32 and COM APIs, and under Win32 and COM APIs, you will see a list. There you go. Alternatives to Windows APIs. That's the link you want. It's going to list all the APIs that have restrictions by category and what the alternatives are. So we can go through them by one. You can go through them one by one. For the rest of this talk, I'm not going to go through it. It's a lot of APIs that are changed. But what I'll do instead is I'll pick a couple of examples that I think are very interesting to us as C++ developers, and go a little bit deeper into what the alternatives are and how you can use them. One thing you will note about this web page is the alternatives are from a language agnostic perspective. It doesn't talk about you as a C++ developer. So there are alternatives that are available to you as a C++ developer in the form of C++ libraries that are even included as part of the Visual C++ compiler, but they wouldn't be listed on this web page. So that's why I'll talk to those separately. Okay. Let's go back to the talk. All right, so I'll take you through a couple examples. One is threading, and the other one is file I/O. Okay? So for threading, so how many people use threading in their application? Most people, right? Okay. All experts at threading? Experts? Experts at threading. Okay. Few experts at threading. Okay. Threading is hard. Threading is very, very important. We use it even though it's hard because it's very, very important. Most people use it because they want their application faster. Anybody use it because they want their application slower? No. So we already know that. We want to create fast applications. So it must be okay from a Windows Store perspective to be able to use threading because, well, you want to make the application faster. That is true, but also you can do a lot of things with threads that are not great from a Windows Store application perspective. For example, ability to create long-running threads that just span the lifetime of your application and longer. These are not things that we exactly want to allow you to do. But also, some of you said you were experts with threading. The rest of you, I'm sure, are also experts with threading. But some developers are not. And this is not only for C++ developers. These are APIs that can be used by JavaScript developers, by .NET developers, by everybody in the world. And allowing everybody to shoot themselves in the foot is scary from a user perspective. So we need really to do this balance between providing a great customer experience, but still allowing the advanced developers to do the advanced things they need, while maintaining some level of compatibility. It's a very tough balance to strike. I can tell you that there were numerous discussions within Microsoft. My team specifically, and I was involved in many of those discussions about what API do we enable, which one do we not enable, and what the alternatives are, and these adequate or not, and what scenarios are going to end up not being able to support. And people ended on multiple parts of that fence, and we're not all on a unanimous front there, but it doesn't matter because what we shipped is what we shipped. So I'm going to approach this talk from a very practical perspective. This is what you have, here's how we work with it, as opposed to trying to justify things that I can explain half of them, and the other half I'm not sure I agree with, but that's okay. So being there, the end result of this discussion is code that looks so innocent like this doesn't work anymore in a Windows Store application. It works in a desktop application, that's not touched. But from a Windows Store application, you can no longer do create thread. Okay? What can you do? Okay. There is a WinRT replacement to that. So there's a thread pool, sort of a higher level of abstraction. It is very optimized for the battery power cases, and it works quite well, actually. And internally, we've replaced the use of traditional threads with the WinRT thread pool for some things, and that has worked just fine for us. And from a performance perspective, a lot of people inside Windows use it, and we really, really worked on tuning it. So I think you're not going to be disappointed there. With that said, some people still need a very, very fine control that this is not going to provide. So some of the restrictions that you have on or the disadvantages of thread pool is, well, number one, as somebody was asking before, is it available in desktop? Is everything available in desktop? This one is not. So if you wanted to do a certain DLL that you want to be able to deploy with your desktop application and your Windows Store application, you don't want it to be using the WinRT thread pool because it just won't work on desktop. The second, the second alternative that you have there is going with some C++ specific libraries. So parallel patterns library, is anybody familiar with it? Less than a quarter of the room. Parallel patterns library is a library that allows a higher level of abstraction for doing concurrency. So instead of dealing with threads directly, you're dealing with tasks and creating task groups and tasks and being able to just quickly launch a worker task, and it does something for you. And it's a lot easier to launch, a lot easier to deal with. The example in the bottom sort of is using the thread pool. The example on the top here is actually using standard ISO C++ threads. So that's also an alternative that you have. So you could go to the higher level of abstraction of parallel patterns library, and that's available across desktop, across Windows Store applications. You could also use standard C++ if you care about going beyond the Microsoft platform, something that works across multiple compilers, and a few of you here are not coming from the desktop world, but from other operating systems. So you might find something like standard C++ APIs available. Our view to this world is any standard C++ code that you write has to compile on the breadth of the Microsoft platforms. We're not going to come to a place and go and say, on this particular Microsoft platform, on the phone or on the store app or whatever, this part of C++ is not available. C++ is available everywhere. That's what it is. Standard C++ is available everywhere. So you can use whatever part of standard C++ and you'll do that. Question?
You were saying that CLI, plus CLI is not available.
Correct.
Now, I assume that there is not standard C++.
Good question. So there was a C++ CLI is not available. I see not standard C++ right here, right? This one, specifically this hat right there. And the ref new, correct. Good observation. Yes, this is C++ CX. So what I was talking about is standard C++, ISO standard C++ is available everywhere. Microsoft-specific editions, they are available where they make sense. Okay? For Windows Store applications, or basically for WinRT, one of the things that we created is C++ CX. It's very, very similar to C++ CLI for targeting the .NET world, with some very notable and important differences. Number one is they are not a binding to .NET. They don't target .NET. There's no .NET runtime coming into the picture here. There's just a mapping to the WinRT runtime. In a nutshell, who's familiar with C++ CX? for those of you who are not familiar with C++ CX, there is a talk in the conference called Deep Dive on C++ CX that talks about C++ CX, how to use it, and why we made it, and all of these things. You should go attend this talk because it will help you figure out how to call the WinRT APIs. It's a very good way of calling WinRT APIs. They're also template-based, like a template library that allows you to call WinRT APIs called WRL. That's also available, but I personally find C++ CX a lot more intuitive. But that's just me. So just in a nutshell, what this allows you to do is think of this as a pointer. It's just the equivalent of a pointer. We call it a handle. And it just adds two things to a pointer. Its lifetime is ref counted, so it's ref counted. We do the automatic add ref and release for you. And the second thing is everything pointed to by this handle will throw. It will throw exceptions. So it'll be an exception-based model. So these are the two key things that you need to know about it. And ref new is just a way of saying, like, I'm newing one of those special pointers. Okay? So here, this is just your standard calling into a WinRT API using C++. So these are options that are available for you. You can use the thread pool, just it's WinRT specific, Windows Store specific. You can do C++ things where it's Microsoft proprietary or standard. Both of these are available. You can also shoot yourself in the foot if you want. Begin thread is available. The bottom three are available on both platforms, desktop and Windows Store. That is correct. Right? So that is also available. And internally, we make sure that the implementation of these things uses the right set of things. Okay. Yes?
So when writing a library for a Windows Store application, SDK, using PPL, is that about 300K to the size of the assembly compared to a traditional Win32? Are you planning to address that? Because most people use lots of libraries with store applications. They're going to get rather large in memory, and that seems to be against the goals.
Okay. So the question was about the memory footprint, memory impact of adding all these libraries. For example, using PPL will add 300K, and you've got lots of these applications running in parallel, each of them adding 300K to the process just because they're using one library. What is it? There's good feedback, and yes, this is something that we're looking at.
You say begin thread. Is that also begin thread EX or just begin thread proper?
Begin thread EX. Yeah.
I'm pretty sure I was getting a complaint from the compiler after begin thread.
You're saying you were sure that you were getting a complaint from the compiler about begin thread EX. The CRT version, the underscore begin thread EX.
Complaining that it is only for the desktop.
I actually didn't know where on that.
Okay, I'll need to look at that. I'm sorry. So you're saying the CRT one, the one with underscore begin thread EX. It might be something that we changed recently, but I'm surprised at it.
It was right between the
The beta.
release market.
Okay, so it was a late breaking change? Okay. Yeah. I can't remember where we ended up. I thought we enabled it, but if two of you have already hit that, then it's not there. Sorry. But yeah, begin thread you should be able to use, for sure. Begin thread EX, apparently not. I'd love to look at it offline. But yeah. But generally, you should be able to look at both the Win32 versions, what is available. Some APIs are going to have Win32 equivalents as well that work across both the desktop and the Windows Store world. And some APIs are going to have just WinRT replacement. In this case, it's only a WinRT replacement. And there are lots of C++ replacements as well. The other one I'm going to look at is the I/O restrictions, file I/O. Okay? Again, isolated storage. You're only allowed to, as an application, deal with certain parts of the file system. You can't go just accessing any part of the user data. So by definition, you get application data folders, whether it's the local folder, the roaming folder, or the temporary folder. These are folders that just every application, Windows Store application, gets access to. But apart from that, you also get to do the ask for more requests, ask for example, the pictures library or some libraries. These are things that you put in the manifest that you can actually say, my application needs access to other places. But you can't just randomly access any other file. So there were also restrictions on the file I/O APIs. And the available options are, instead of doing create file, you can do the WinRT storage APIs in the Windows storage namespace. Or obviously, you could use the ISO C++, streams and file system from TR2. So new WinRT APIs. There are so many to go through. We'll not go through all of them here. This is more of an eye chart than a list of APIs. All the APIs are listed in the same web page that I had pointed to earlier. But the key thing to notice about these WinRT APIs is that you'll find that most of them use a pattern, which is the asynchronous pattern. Most of these APIs, you call, and then you don't block. You continue execution, and then you resume later when you get a result on some other thread. It's a common pattern for WinRT APIs. You're going to find that you're going to have to deal with it more often than you even want to. In some cases, even when you want to do a blocking call, you're sure that something is going to be short, you're going to have to deal with an async API. This is because we really, through our experience, we saw that a lot of the spinning donuts that are happening are based on just blocking I/O. And you'll see that in many other APIs, not just the file I/O APIs as well. So we're really moving to an async pattern for most APIs for WinRT. So how do you deal with that pattern? I talked very shortly about C++ CX. And this is sort of the pattern using C++ CX. You have an operation that you want to call. This is the important call that you want to make, right? And this is an async operation. And it returns some type. This is the return type for that operation. So what you're doing is you're getting a handle to that iasync operation. The operation starts, and what you're getting is a handle to that operation, the async operation that's happening in the background. Now, when the operation completes, you can add a handler that tells you when the operation completes what to call. In my case here, I'm just going to do it through a lambda as opposed to provide a function pointer. You could also provide a function pointer or some form of function pointer if you wanted to. And in this lambda, I can get the results, and then I can do whatever it is that I want with it. Code looks ugly. I don't love it, so that's why we have this simpler implementation. This is using the parallel patterns library. So what you do is you get a task pointer to that operation. So you invoke the operation, and then from there have a continuation, very similar to JavaScript continuations. Just do a .then, and inside there you have the result as a parameter, and you can execute with it. It does roughly the same thing. Yes? Does this require the use of CX, or does this can be used from standard C++? You don't have to use CX. C++ CX is there for convenience. You have an alternative which is called the Windows Runtime Library, WRL, and you could use WRL everywhere you would have used C++ CX. It's just wordier and lengthier, but if you like the kind of code that you use in ATL, this would be very similar. Yes? Are the lambdas in C++ CX different than the lambdas in C#? So these are actually not C++ CX lambdas. This is standard C++ 11 code. So the lambdas from here are just standard C++ 11. I'm not very familiar with lambdas in C# and what the syntax and what the semantics is exactly, so I can't compare the C++ standard lambdas to C# standard lambdas. But this is not C++ CX specific. This is 100% standard code if it was invoked with some other type. Yes? Can you use standard features? Absolutely, you can use standard features. Standard threads, standard features, all that kind of stuff you could use. Oh, for this pattern? I have not tried it. I don't know why you wouldn't be able to, but I personally not tried it. I think you should be able to. So this is sort of a more complete example of what it would look like in the, you want to create a file, you want to write some things to it, and then you want to read them. This is what it would look like using asynchronous APIs. You have a call to the create file async. This is the Windows API. Then you have write text. Then you're going to get file async, and then you're going to read from it. And this is all happening asynchronously, and the continuations tell you when this happens, that's the code that gets executed. So you have a question in the back, but before I get your question, one thing to note is the lifetime here. It is very important to watch the lifetime, because let's say this is within a function scope, and when you execute, this statement, then statement 4, and then you go, the function, let's say the actual operation hasn't completed, all of that stuff is going to be executed after you exit the function, which means that scope is destroyed. So if here in the capture clause, you're capturing stuff from the local scope and you're getting it by reference, not by value, you're going to have lifetime issues. So you need to make sure that you're using the right kinds of pointers to point to things. I had a gentleman in the back. He had a question. Okay. The question is, what is the underlying mechanism of how this works behind the scenes? Let me take that one offline because it would be a longer discussion. But yes, there's a separate thread that some stuff executes on.
I guess my question was pretty similar. Are you guaranteed that these things, that the continuation is going to happen on a separate thread, or is it possible that it could happen on a thread?
Yeah. Are you guaranteed that the continuation is going to happen on a separate thread, or can it come back to the UI thread? In this case here, like I think there are some things that you need to set on in terms of which thread you want it to come back on. So you could actually specify where it comes. Generally, you can't guarantee where this is going to be. Are there synchronous versions available? For some, there are. Some being very, very, very few. Majority, absolutely not. Yeah, so the question is, roughly, if you're going to simulate blocking calls with asynchronous APIs, the code looks uglier. Yes, but what we're looking for is people not doing that, because you still get the donut. Yeah. But, yeah. This is really the last thing we're going to go through. So WinRT components. This is just a way for you to expose your libraries to other languages. So it's valuable for you as an application developer, as well as a library vendor. Both of them make it possible for you to expose your application to other languages. So this is typically how you access C++ code from C++, calling it directly. JavaScript or C#, how do you do that in the Windows Store world? You create this little WinRT wrapper on top of existing C++ code, and it allows you to do the DLL and the WinMD file that can then be used from JavaScript and from C#. You could also call it from C++ if you want to, but there's really no need for it. Probably be less performance than calling C++ directly. This is just a demo of how we do the same thing for the OpenCV library. So this is an HTML application that uses OpenCV. And what I have here is a C++ project that creates a wrapper. And that wrapper calls into the API underneath that is strictly C++. So you're basically having a C++ CX WinRT wrapper, and that wrapper makes it available to call from C# and from JavaScript. And in my application here, I'm just calling it from JavaScript. The wrapper that I have here is actually I created a WinRT wrapper on top of a standard C API. So that's basically it for the talk. I think that if there's anything to conclude here is it will take some work, moving from desktop world to the desktop world to the Windows Store world is not just a one-step process that's very simple. But with that said, you can actually very possibly take your existing C++ code and move it to the Windows Store world. I'll take questions at the end. I'm going to stay here for